Alright, boys and girls, welcome back to the drive-thru. Hope you're enjoying your little beginning to your algebra mission. Maybe you're watching this and following along to fill in your workbook. That's fine. Maybe you're not watching this at all and you're trying to do your workbook without the help of the video, and that is totally fine too. The most important thing is that when you're doing these little introductory lessons that you read and think for yourself. Don't just watch these videos to write down what I write down. Make sure you're listening to the videos, pausing the videos, reading the worksheets, and thinking about what the answer is or what the question is asking. So describe and label the pattern is the first question it asks. So obviously the amount of dots are increasing. At the beginning there are 3 dots, 3 sets of 1. Then there are 3 sets of 2, so we got 1 here. 3 sets of 2 is 6. Then we have 3 sets of 4, 12. Then we have 3 sets of 8, 24. And then we have 3 sets of 16. Okay, so the best way you can describe this is that the amount of dots is doubling every time, starting at 1 times 3 is 3. Okay? What I'll do here to answer question number 2 is I'll make a table at the beginning. So after 0 minutes, we had 3. After 1 minute, we had 6. After 2 minutes, we had 12. After 3 minutes, we had 24. And after 4 minutes, we had 48. So at this rate, how many dots will there be after 5 minutes? It'll be times 2. Times 2, times 2, times 2. So it's going to be 96 dots. Write a recursive formula to describe how many dots there will be after t minutes. Okay, a recursive formula is a formula that is based on the previous t. Okay? So, f at t minutes will be 2 times f of t minus 1. So you take whatever it was last time and double it. So what was f of 4? Notice that f of 4 is equal to 2 times f of 3. Okay, f of 4, the function at 4, is twice f of 3, the function at 3. Okay, write an explicit formula on how, now this is going to be much harder for you. Okay, so the explicit formula is y equals f of x. So not what is it based on the last one, but what do we put in to get our answer? When we put in an input, what is our output each time? How did we get from 0 to 3? How did we get from 1 to 6? How did we get from 2 to 12? Okay, let's see. Well, this is probably why you're watching the video. This is hard for you to come up with. So some things I need you to remember. What is t to the 0? Anything to the 0 power is 1. Maybe you've learned that before. We will go back over that throughout this year. Okay? What is t to the 1st? Well, that's t times t. Okay? So notice, this thing here is 3 times 1. This is 3 times 2, 3 times 4, 3 times 8, 3 times 16, and 3 times 32. So it's definitely going to be y equals 3 times something. You can see that's consistent. Okay. Notice this Let's just look at this blue one. Look at all these blue numbers. 1, 2, 4, 8, 16, and 32. Well, this is 2 to the 0 power. This is 2 to the first power, 2 squared, 2 cubed, 2 to the fourth, and 2 to the fifth. So, I think that answers our question. The answer is 3 times 2, 3 times 2 to the t power. And that's going to be brand new for you guys. So you were going to need the video to come up with that answer. If you came up with an answer and it was wrong, that is just fine. Just correct it and see if you can learn from that process. All right, so it says, use the given table to identify the indicated value for n. And then part B, then using the value for n that you determined in A, use the table to find the indicated value for B. Just so you know what the heck, it's like if you have a function. What is a function? Well, it's like a mathematical machine that you plug in a number. So you plug in a number, like let's say you plug in a 10. Number 10 gets plugged in. Well, this, you put 10 in for x. So what's 5 times 10? 50. 50 minus 13 is 37. So you'd say the function at 10, or the function of 10, or f of 10, is equal to 37. So this is f of 1 equals negative 8. When you put in a 2 for n, you get f of 2 is negative 3. F of 3 is 2, okay? All right, so when f of n equals 12, that's here. What is the value for n? The value for n is 5. So what would be the value for f of n minus 1? Well, what's f of 4? The value would be 7. These are some weird ones. If f of n is 17, sorry, this should be 7. If f of n is 17, what is the value for n? It is 6. What is the value for f of n minus 1? F of 5 would be 12. Okay? When f of n is 32, what is the value for n? N is 9. What is the value of f of n plus 1? Well, that would be f of 10. And f of 10 would equal 37. So we're reading our chart. When f of n is 2, what is the value for n? The value for n is 3. What is the value of f of n plus 3? What's 3 more than 3? 6. F of 6 is 17. We already had that one. F of n is 27. The value for n is 8. What is the value of f of n minus 6? What's 8 minus 6? It's 2. F of 2 is negative 3. When f of n is negative 8, what is the value for n? N is 1. What is the value of f of n plus 9? Well, n is 1, so n plus 9 is 10. And f of 10 equals 37. This is a concept that students struggle with in their entire algebra career. So this book is just going to keep giving you practice at this. That's what these videos are for. If you didn't know what the heck it was asking for, then that's what the video is for. Okay? Use the given information to decide which equation will be easiest to use to find your indicated value. Then find the value and exploit your... So we have the explicit equation is y equals 3x plus 7. The recursive equation is the one we have now is the previous item plus 3. Find the value of the fourth term. I think the easier way to do it is to put that into the explicit equation, because you would just do 3 times 4 plus 7, which is 19. Let's see, the explicit, equation allows you to plug 4 into the expression. Okay? Okay, well, the value of the 50th term, we don't know. Maybe, I guess they're going to say this one might have been easier to use the recursive. Just take 16 and add 7. That makes sense, okay? Sorry, just take 16 and add 3. Just take 16 and add 3. I don't know which one's easier. It doesn't really matter. It's just my opinion, man. This one, we cannot do the recursive because we don't know the previous term. So we have to do 3 times 50 plus 7, which is 157. That's the only way we could do it. Okay? Find the 20th term. Well, we have the value of the 8th term, but we don't have the value of the 19th term. So we're going to have to use the explicit. The recursive does not help us. So to find the 20th term, you do 10 times 20 minus 2, which is 200 minus 2, and 198. Okay, the value of the 8th term is 78. The sequence is increasing by 10 at each step. To find the 9th term, we could just take the 8th term and add 10. So we're just going to call this 88. That was easier. Slightly, I guess. Slightly easier than using the explicit. Okay. Number 11. The value of the 4th term is 80. The sequence is being doubled at each step. Find the value of the 5th term. Well, we don't have the 4th term. So what we're going to have to do is plug in a 5 for x into the explicit equation. So y will equal 5 times 2 to the 5th power, which is equal to 5 times, let's see, it's 2 to the 5th, 2, 4, 8, 16. It's 5 times 32, and I believe that is 160. Okay, the 4th term is 80. Oh, no, it would have been totally easier to use the recursive. I didn't read that closely enough. Take the previous term, so to get the 5th term, take the 4th term and double it. But that's good. That just confirms that we did it right. It works for both of them. The 4th term is 80. The sequence is being doubled, so now the recursive doesn't work. They want the 7th term, so it will be 5 times 2 to the 7th equals our answer. Well, 2 to the 5th was 32, so 2 to the 6th would be 64, and 2 to the 7th would be 128. Yep, so it's 5 times 128, which, let's see, what is that? So that is 640. Okay. One more page. Evaluate the following equations when x equals 1, 2, 3, 4, and 5. Organize your inputs and outputs to a table. Let x be the input and y be the output. Okay, so y equals 4 to the x. Well, 4 to the 1 is 4. 4 squared is 4 times 4. It's 16. 4 to the 3rd is 64. Notice I'm just multiplying the previous one times 4. 4 to the 4th is 256. And 4 to the 5th is 1024. Look how big that gets. Exponential growth. Okay? -3 to the 1st is -3. Negative 3 squared is negative 3 times negative 3. That's a positive 9. Negative 3 cubed will be negative 27. So notice we're multiplying by negative 3 to get from one number to the next number. So negative 27 times negative 3 is positive 81. And negative 3 to the 5th is the same thing as negative 3 times the previous number, and that's going to be negative 243. Okay? Look at the difference between this one and the last one. Negative 3 to the x. Remember, please excuse my dear Aunt Sally. So we got to do exponents first and then multiplication second. So this really says negative 1 times 3 to the x. That's the same thing. That's confusing. Math people are lazy, and sometimes that makes things confusing. So they basically eliminated the parentheses and the multiplication and just wrote it like this. So we got to do the exponent first, is what I'm telling you. 3 to the first power is 3 times negative 1 is negative 3. 3 squared is positive 9. Positive 9 times negative 1 is negative 27. Sorry, negative 9, negative 9, negative 9. 3 cubed is positive 27 times negative 1 is negative 27. You're going to recognize this as always the negative version of these answers over here. Notice the difference between this one and that one. That's a great little exercise. And this one will be a lot easier to do in our head. 10 to the first is 10. 10 squared is 100. 10 cubed is 1,000. 10 to the fourth is 10,000, and 10 to the fifth is 100,000. Hope this helps. Good luck on your homework. Boom!